guys, today we're going to learn how to solve an equation for a variable. Our learning target is I can rearrange an equation to solve for a variable. Let's just start out with, so far we've been working on solving equations for unknowns. Unknowns such as x, which is a variable. We've been working on what happens if there's only one value for x that makes it true, if there's no values for x that make it true, or if there's infinite values of x that make it true. So if we were given the equation 2x minus 7 equals 3, what do you think right away? Is there going to be one value, no values, or infinite values that will make that equation equal to 3? I hope you said one value because it seems like it might work out that way. It turns out that the way we have the equation written so far is that it is actually solved for 3 because it equals 3. I can rearrange this equation however I want to in order to solve for something else. So it's already solved for 3. Let's try solving it for 7. What is keeping me from having 7 is equal to? I hope that you've identified that there is a term in the way, a variable term in the way, and that unfortunately we have a negative 7. I'd like for you real quick to just think about how could you solve this equation for the 7 instead of for the 3? Alright, I could subtract 2x from both sides. In doing so, I'm eliminating that term from this side of the equation and applying it over here. What do I end up with? Negative 7 is equal to, how can I write 3 minus 2x? Can I combine those terms and make it 1x? In fact, I can't. This is a term, which is a constant, and this is a term, which is a variable, and I cannot combine them. So I just write it out like it says to. So right now I have it solved for negative 7. My goal is to solve it for a positive 7. So I can divide this side by a negative 1 because negative 7 divided by negative 1 is a positive 7, and that gets me what I want. So if I divided this side by negative 7, I have to keep my properties of equality equal, so I need to divide that side by a negative 1. 3 divided by negative 1 is a negative 3. Negative 2x divided by negative 1, a negative divided by negative is a positive 2x. So now I've solved my equation for 7. I could also solve my equation for x, and that's what we've been practicing in class a ton lately. So let's go ahead and restart over here. I'd like for you to pause me right now and try this on your own. Thank you. Hope you got x equals 5. That's if I solve the equation for x. Alright, so let's go ahead and move on. Why is this useful and where do I use it? These are two great questions because sorry, I'm sick and I don't feel good. Two great questions because there is various different situations where I would need to use this. Let's try this. How do you find the volume of a cube? If this is my little cube, how would I find the volume of this cube? The volume, remember, is all the space on the inside. I believe the equation is equal to volume is equal to length times width times height. Because we find the area of the base is a square. That's why we get length times width, because it's the area of the base, and we multiply it by the height of the figure. So what if I told you that the volume of this shape was, I don't know, let's try it, 30. I'm going to write that over here. Volume equals 30. Let's say that it's in milliliters. And then I told you that the length was equal to 5 and the width was equal to 3. And I didn't know what the height was. I find this useful because I can substitute all of these known values directly into my equation. So I can put the volume is equal to 30. So I've substituted in 30 for volume. I'm going to substitute in 5 for the length. And I'm going to substitute in 3 for the width. And I'm going to substitute in h for the height. Not really substituting anything. However, then I can go ahead and I can solve for h. If I did that, I would simplify by combining like terms. These are both 5 times 3. I can rewrite that as 15h. Then I can divide both sides by 15, and I can divide both sides by 15, and I can get that the height is equal to 2 milliliters. This is useful only because we knew all the values. So real quickly, I want to just grab the eraser and I want to erase all of these nodes and pretend like I don't know what they are. Could I rearrange my original equation, v is equal to length times width times height, and solve for maybe the height without knowing any values? So volume is equal to length times width times height. The only operation that I have, let's say I want to, sorry, skipping ahead. Let's say I want to solve for h. The only operation that I have is multiplication here. So I can undo it by doing some division. So I can divide both sides by whatever the length times the width is. That's exactly what I did here. I figured out what the length times the width was and I divided by it. And then I divided 30 by the length times the width. So I can divide the volume by the length times the width. And I can say that the height is equal to whatever. Oh, sorry. I meant to say whatever, not write whatever. Here we go. That the height is equal to the volume divided by the length times the width. So now I've solved this equation for h. Let me give you another example. Here's one that you've been working with commonly. Density is equal to the mass divided by the volume. If I asked you what this was solved for, you could tell me that this equation was solved for the density. I can also rearrange this equation to solve for the mass. So let's try that. What operation is being done to the mass? I believe it's being divided by the volume. So I can undo dividing by volume by multiplying by volume on both sides. That cancels out my denominator. I'm left with just the mass is equal to volume times the density. Now it's solved for the mass. What if I wanted to solve density is equal to mass divided by volume for the volume? Unfortunately, I don't know what's being done to the volume because it's in the denominator. It's what's being divided by. So I need to rearrange my equation by getting my volume into a different spot. In doing that, I'm taking the same first steps that I did before. I get volume is equal to volume times density is equal to mass. Still doesn't help me because I want to isolate my volume. So what's being done now to that equation? It's being multiplied by the density. So I can divide by the density. That cancels out my densities over here, and I'm left with volume is equal to the mass divided by the density. So starting out with our original equation of density is equal to mass divided by volume, I've resolved it for the mass. I've resolved it for the volume as well. So I can rearrange any of these equations just like I can with any other type of equation. I'm just choosing what I'm actually solving for.